Quadratics, what you need to know for Tuesday. My opinion that quadratics forms the basis of this study. So much springs from it. You'll use it in so many different contexts. It's very important to understand the geometric principles that underlie a lot of the procedures that we're going to be looking at. And I cannot overstate how important a thorough understanding of quadratics is. I'll try to do some justice to what I hope to ask you on Tuesday. I don't have a particular order at this stage. We should look at the parent function. I have this, and this is something that was written before I even came in. So you know what we've been talking about. Quadratics, four-sided figures, rectangles, and there is a most important rectangle, and that is the square. And so we'll begin there, and I hope you can see that the areas decrease. And then there is no area on the 0, 0, and then 1, 1, 2, 2, 3, 3 increase. And in calculus, you actually learn the rates at which all of this happens, and that still comes from drawing squares. So we get this U-shaped graph. That's the parent function, y equals x squared. And what we're starting to learn how to do is to graph other quadratic relationships. And you've even seen the marker go up to 67 feet high and come back down to 3. And we've been writing that equation to show you that we use these constructions, which are often called functions, calculations. Let's just study real, how you doing? Motion problems, right? Gets us started with that study. So what am I going to ask? I'm going to ask how to graph a trinomial. And I'm just going to give you the bare minimum here, because otherwise this lecture could last for a couple hours. So how would you graph that? Well, hopefully you recognize that it's a positive a term. So it's a cup shape up because that's the dominant function, squaring. We'll look at this in greater detail going through the rest of the semester. Rome wasn't built in a day. I hope that your brain has already said, oh, x equals minus b over 2a is what the old guy's been saying for the first 4 or 5 days. So you actually do that. So this is in the form of ax squared plus bx plus c. So I hope everybody knows that b is negative 20. And we're doing the opposite of that, positive 20. And we're dividing it by 2 times a, and 2 times 2 is 4. So we automatically know that that's 5. And we know minimums from looking over there come from 0 squared, right? So therefore, well, I just asked you to sketch it, so I'll come back to that later. So we've got an equation that tells us out the y values. I'm supposed to do what? Take the 5 and square it and multiply it times 2. That's not 100. You do the squaring first before you multiply. Minus 100 plus 7. And if you do that out, I believe you get negative 43. Right? And this would get you half a point. Well, actually, I usually give 2 points for graphing. That would get you a full point. You know the shape and you know the vertex, but unless it goes through another point, you don't have an accurate graph. And I've been asking you to find the y-intercept because it's given. It's 7. You put a 0 in, you get 7 out, and that gets you a check. Maybe even 2. I got to decide on Tuesday. I might give you 2 for getting a proper sketch of one of these things. Usually important. And putting it in graphing form, well, we got everything we need. We got the a term. So I'll ask you to put it in graphing form. You've got the 8. I think you sketch it first. I think that gets us 2x squared. And 5 negative 43, very similar to the thought process that we used in the linear constructions. Right? So that's what that is. Now, the next thing is expanding statements like this. Expanding statements like that so that we can get back to the trinomial. That's also going to be asked. So let's see. Well, we'll just erase this And I hope you can see also that if, well, now let's just do the question I asked. Yes, you can see everything. So what do you have to do first? You have to do the squaring, and the squaring is this, x minus 5. X minus 5 is the side of the square. And I'll write x minus 5 here because there's 4 parts to that, not drawn to scale. There's an x squared part, there's a minus 5x part, there's another minus 5x part, and we're heading into completing the square here. And minus times minus is positive 25. And so what does this thing equal? Well, so far it equals 2 times x squared minus 10x plus 25. And some of you have heard me talk about the shortcut of binomial squaring, which we will be studying in a moment. We'll give you another problem there. There's a relationship here where I don't have to draw this out. I don't have to do x minus 5 times x minus 5 because I can see these numbers coming from that process. And you should take a moment and try to see them too. So what's the final answer? Another way of writing this is y equals 2x squared minus 20x plus 50 minus 43. And I do believe I know what 50 minus 43 is. It's 7. Oh, yeah, that's what I started with. So that's just a skill. That's going to be on there. So let's do one more. And I'll show you the way I'll be writing it and why I'm writing it that way. So let's say you have let's say you have 5 minus 3 x minus 2 squared. And I want it in the ax squared plus bx plus c. I'm writing in this way because I want to see if anybody makes the mistake of saying 5 minus 3 is 2, which means you're not reading math in the correct order. You need to square that. And I'm hoping you may have already figured out the pattern. Positive 5. I'm going to do that again. 5 minus 3x minus 2 squared. 5 minus 3x minus 2 squared. Because I want folks to know that 5 is positive, which means I'm really adding 5. And it might be useful for you to put it there. Because now you can see you have a cup-shaped graph down at 2, 5 is the vertex, and that's helpful to know. Okay. All right, so minus 3 times, back to where we were, x squared minus 4x plus 4 plus 5. This is what you'll be asked to do on Tuesday. Gets us minus 3x squared plus 12x. Minus 3 times 4 is minus 12 plus 5. And if you correctly add minus 12 and 5, I believe you get the opposite of 12 minus 5, which is negative 7. All right. You're on an exam. You want to make sure you didn't make a mistake. Let's put a number in. Whatever I get here, let's put a 3 in. That's not a tough number to work with. 3 minus 2 is 1. 1 squared is 1. I get minus 3 plus 5, which is positive 2. If I put a 3 in here and I don't get positive 2 out, then these calculations are not equal. So I'll put a 3 in. 9 times negative 3, negative 27. 3 times 12, positive 36. Minus 7. Well, I know 36 minus 7 is 29, and 29 minus 27 is 2. They are indeed the same calculation. Could there have been an easier number to plug in? Probably. Probably could have easily plugged in a 0 here first and gotten negative 7, and then put a 0 in here, and that would have been minus 3 times 4 plus 5. Which we looked at before, minus 12 plus 5, negative 7. Just thought I'd mention that. All right, so what else do we have? Well, we got to figure out how to do the FOILing process. X plus 3 times x minus 8. All right? And that's the same thing as x times x minus 8 plus 3 times x minus 8. You don't have to do that out. You could simply go here and say, well, I'm doing x times both of these things. All right, that's x squared minus 8x. Then I'm doing 3 times both of these things. 3 times x is 3x, and 3 times minus 8 is minus 24. And then these are like terms. You get x squared minus 5x minus 24. Okay. And then whatever you do in one direction in math, you're going to do in the other. You're going to write this as a product. And hopefully you would say, well, I know how to get the first term. You know, trinomial factoring is what it is. A lot of people don't know what factoring is. Factoring is taking sums and differences and writing them as products. And there's a good reason to do that. We'll explore that reason later in the term. Right now, it's just, can you write that? Well, if you pay attention to the process, something times something gets you 24 or negative 24. So I guess we have to have a plus and a minus. And those two things combined in the middle to be 5. So you're looking for factors of 24 that somehow add up to 5 in this instance. Well, 1 and 24 doesn't look too good. 2 and 12 doesn't look too good. But 3 and 8 sure does. And we want it to be a negative, minus, plus, and you have not had a lot of practice with that. You're going to get a lot of practice with it in a little while. But I'm still going to ask it. So let me give you another one and see if you can figure out what to do. We'll just keep everything positive this time. X squared plus 6x. Oh, plus 6x, and let's find out if we can get 7. Not much choices here. X plus 7. I didn't give you one that worked. Make that a 5. All right. So there. Sorry. X plus 5 times x plus 1. Yeah. 1 and 5 add up to 6. All right. So let me think a little bit more on the next problem before I give it to you. So how about we do x squared minus 4x? That's good. And minus 21. And you try it. How would I write that as a product? Yeah, I think I could do x and x again. Factors at 21 that have something to do with 4. It sure looks like a 3 and a 7 to me. And I want the negative. Huh. I guess I'll do that. What if I wanted the positive? Then the positive wins out. This is what we're going to be studying. All right. And what's another question that might be asked? Well, 3x minus 2 squared. Where I make the number a little bit bigger. And I'm hoping you square the first term, double the product, but you might have to, and you probably should write it out like that, right? Why is it a quadratic? Squaring something gets you area. What are we really doing? We're doing 3x minus 2 is one side of a square. 3x minus 2 is the other. They got to be the same. And you're trying to come up with the area of 9x squared. Doubling that product gets you minus 12x. Squaring minus 2 gets you 4. And if you're not getting that, you better go to math help and find somebody to help you out. Or you got to speak up in class and say, hey, can you explain this to me a little bit more? Can you give me a couple in class? Okay, you got to take some ownership of your education here. All right, and ownership during our workshops, which we'll get back to, is not standing there waiting for me to come by to help you out. You might stand there for too long and waste your opportunity to get some work done in class. Always go to the next problem or look for somebody who's done it. Say, hey, can you help me with that? Idle standing around, not going to get it done. So what other question might you have asked? Let me see. I did, roots. Right? And yes, somebody said, what's a root? Well, here's the ground. Here's a tree. This is my 3rd grade drawing. And here's roots. And we're trying to find the roots, which means we're really looking for where a graph intersects the x-axis. Okay. So let's look at where 2x minus 5 squared plus No, I don't want to give you that yet. Minus, let's give you something easy. Minus 20 equals 0. Well, see if you can follow this. 20. 10. Plus minus the square root of 10. 5 plus minus the square root of 10. Leave it there, think about it. Numbers should speak to you as to what I just did. And you got to look at it until they speak to you. All right. Then let's look at, see if it works. 2. 5 plus minus the square root of 10. Yeah. Minus 5 squared minus 20. Let's see what we get. Sure looks like the 5 minus 5 cancels. Sure looks like when you square a plus or a minus, positive times positive is positive. Negative times negative is positive. Sure looks to me like when I square the square root of 10, it's an inverse operation. And it looks to me like I got 20 minus 20. You know what? I think it equals 0. First stage of learning is following. If you didn't follow it, back up the video, play it again. Play it again, Sam. Yeah. Okay, what else do we have? Let me see. So hard to remember all the things we're going to be doing. Graphing form, expanding I talked about, sketching I talked about, finding roots, products, factoring. Yeah, we'll be factoring. And oh yeah, let's find a product that's a little harder. Let's look at 5x to the 3 minus 2y to the 4, and let's square that. And I'll take more time with that because you're just learning your algebraic skills. So I've got, and I'll do this one out for you. 5x to the 3 minus 2y to the 4th times 5x to the 3 minus 2y to the 4th. All right, we know what 5 times 5 is. It's 25. And Tiffany's handout shows you what x to the 3 times x to the 3 is. Look at that handout, x to the 6th. Then we have 5x to the 3 times minus 2y to the 4th. I don't know what x to the 3 is, and I don't know what y to the 4th is unless I put some numbers in. But I do know, and this was on your sheet, that a to the 4, b to the 4, and I had a question mark on a worksheet. You can't say anything because they're not the same base. If you add a to the 4th and a to the 4th, well, yeah, that's a to the 8th. There are rules governing that. And I know what a to the 4th to the 3 is because there's rules governing that. So I can't do anything with minus 10 x3 y4. That's all I can say. But I'm doing it again. Minus 10 y3 x3 y4 x3. I'll write as x3 y4. And then I can do minus times a minus is a plus. And I can do 2 times 2 is 4. And I can say what y to the 4 times y to the 4 is. And then these terms in the middle, whatever that product is, I've got it over there. I can tell you how many of those products I have. Minus 10, minus 10, minus 20 in the middle. So final answer, 25x6 minus 20x3y4 plus 4y8. And what I'm telling you right now is I'm giving you one of those on Tuesday. What else have we covered thus far? And Lord, we're only scratching the surface. So much to learn with quadratics. What do we got? Let me see. All right, so linear, we have learned, we're starting to learn a x minus h plus k form, which is not in the textbooks. I wish it was, because we now have a x minus h squared plus k under consideration. And this model works all the way up through however far you want to take it. X to the 1, X to the 2, X to the 3, X to the 4, X to the 5 gets a little complicated down here. And I'm not going to worry about it with you. But these two right now are on the table. So products, factoring, graphing forms. Okay, we got enough. We got enough. And that's about a third of what I'm hoping you learn this semester. Okay, so that's where we're starting. Okay, do I need to maybe I'll give a quick worksheet right now. I'll just do those real quick again. So you got a little more practice and you can stop the video, but I'm just going to do it mechanically. All right, so we started with y equals, I'll do -2 this time, x squared plus 12x plus 3. All right, I know it's cup shaped down. You're stopping the video. All right, you're stopping the video. I know the vertex comes from minus b over 2a on the x side. And then f of minus b over 2a on the right. Because I could have, instead of saying y, I could have said, hey, this is a calculation based on, you know, the letter x or some numbers plugged in there. So minus b minus 12 over -4 is a 3. So that tells me y-intercept over here is 0, 3. And take that, which happens to be on the increasing side. I can show you why later, the shortcut to that. So the only thing I'm missing right now is what goes with the 3. And I can plug that in. So if that's 36, that's got to be minus 18, and that's got to be 3. And I put those things together, and I get 18 plus 3 is 21. There you go. That's got to be worth 2 points. There's a lot to do in that. Okay, so if you get that right, Tuesday, you're getting 2 of those. And I'm saying it fast, but you can always back it up and play it again. I learn step by step. It's about, what, 4 or 5 things I did there? Okay. And then, oops, I didn't want to do that. 321, 0, 3. We also want to be able to write that in graphing form. 321 simply means x minus 3 squared plus 21. We'll talk about the geometric implications of that more later. And oh yeah, major topic, 2 points and another. Well, we'll see this number pop up here with that process. So how do I get from 21 down to 3? How do I get from 21 down to 3? I have to go down 18 units. But what happens when I put a 0 in here? What happens when I put a 0 in place of x? I get 9 units. I don't want 9 units of change. 9 units of change is going up 9. Certainly doesn't take me to 3. So I got to go in the other direction, and I need 18. That's just a little bit of help there. So now I'm going to give you a random one. Can't believe I didn't think of that here, but I didn't. All right, this is major. This is major, right? So 5, 7. Random number. 11, 100. Can you write that equation? Well, I want that to act like a minimum. Minimum square area is 0. So I've got to start with x minus 5 squared. When I plug 5 in, that number disappears. And I want 7. This is an area statement. It's x minus 5 times x minus 5. And what I get when I put 11 in is 36 units of area. So I go over 5 units, I go up 36 units. Didn't get me to 100 from 7. 10 only took me to 43. I don't want that number. I want the number that takes me from 7 to 100, 93. And you're trying to see the zeros and ones that happen. When you put a 5 in, this is a product, right? And the 2 easiest numbers to multiply by are 0 and 1. And that's what we've generated. When you put a 5 in, you are creating this number times 0. And when you put a 11 in, 11 minus 5 squared is 36, which doesn't work. So we do a quick conversion to what does work. And if I keep saying that each and every day, I hope the neurons in your brain eventually connect on that. That's what we're working towards. I can only tell you what it is, not what it isn't. Okay. So that's really important, and that is definitely going to be asked on Tuesday. All right, what else? Well, let's see. Products, factoring, binomial squaring. Oh, we're practicing. All right, so how about 5x minus 7 squared? One more time. Square the first number. Minus 7 times 5 is going to happen twice if you take the time to do it out. So therefore, minus 70x plus 49. And I want to put a plug in again for math help at night. There's nothing that says you can't come down here and just spend a half an hour. Don't spend, you know, we're tackling so many distributed learning. You're tackling so many topics, you probably drive the help person nuts who's you know, trying to help other people, because you can continue asking for it. Just set a goal of 2 things. Learn 2 things tonight. Come down here and work on them, and then leave the building going, I know 2 more things that I didn't know before. You do that, you're going to do so well in this class. You'll be happy, and so will I. What else? Well, I'll probably give you, you know, this is how I make up problems. 3x plus 2 x minus 5. Well, that becomes 3x squared minus 15 plus 2 minus 13x, 2 times 9 minus 10. That's a trinomial. It's a little harder to come up with. What did I, you know, just use there? Well, you gotta put things in that help you move in the right direction. As in, it must start here, right? Boom, you got the first term. 10 can only come from 1 times 10, 2 times 5, 3, 3. That's it. Those are the only 2 numbers, yes? And then plus minus, of course. And I'm putting this column right here because when you multiply, each of those numbers is bigger by 3, a factor of 3. So really, I'm looking at the numbers 3 and 10, and I'm looking at 6 and 5, and I'm trying to look and say, what gives me 13? Did I make a mistake on this? I also have to have 5 and 10 here, sorry. 5 and 10, all right, which means I've got 5 times 3 is 15. Where the heck am I? Let's go back and do that again. 1, 2, 5, 2, 10, 1. There, that's what I meant to say. All right, so if I do 10 times 3, I get 30. Well, that's not in this ballpark. If I do 5 times 3, oh, that's 15 and 2. Bingo. So I wanted the 5, and I wanted the 2, and I wanted to be negative, and I wanted to be positive. And, you know, even I took a moment there to, you know, just for a second there, I was off base, corrected it, right? Because I didn't get what I wanted. And that's going to take some practice, right? So at some point, we're going to have to, not yet, because we want to get a lot of things in front of us, but at some point, got to give you 4 or 5 of those a row each day, 4 or 5, so you get some expertise with it. All right, let's see. Anything else that I want to talk about for quadratics for Tuesday? No, I don't think I do. But let me just show you how important the quadratic is. No, I won't. That's enough. You're already overwhelmed. So we'll stop there. Bingo. All right, and we'll see you on Tuesday, Monday, and later today.